In this pod, we'll investigate the relationship between force, mass, and acceleration by varying the masses added to trolleys. Before starting this investigation, it would be useful to have a reminder of Newton's laws of motion.
Newton's first law of motion is, an object will stay in its present state of motion unless acted upon by an external force. This means a force needs to be applied to make an object increase or decrease its speed, or change the direction of its movement.
Newton's second law of motion is, a force applied to a mass will cause it to accelerate or decelerate. The acceleration or deceleration is proportional to the amount of force applied to it. This can be described by using the formula resultant force equals mass multiplied by acceleration, or F equals ma. This equation can also be rearranged to give A equals F divided by m. This form of the equation shows that the acceleration will increase if the force applied increases, and the acceleration will decrease if the mass of the object increases.
Newton's third law is, if object A exerts a force on an object B, then B will exert an equal and opposite force on A.
It is the second law that you're going to look at in this investigation. For this, you will need a track and a trolley. You may instead be provided with an air track and vehicle. You'll also need a pulley, a cord, some masses, and a speed sensor. You will then need to set up the equipment as shown.
When your equipment is ready, give it a trial run with some masses on the end of the cord over the pulley. If the masses you use are standard 100-gram masses, each one will have a weight of 1 Newton. This is because 0.1 kilograms multiplied by 10 equals 1. How did we get this figure? The weight is the force applied, which comes from the equation F equals m multiplied by g, where m is the mass and g is the acceleration due to gravity. The acceleration due to gravity is 9.81 newtons per kilogram, but we usually round it to 10 newtons per kilogram.
Hold the trolley at exactly 1 meter from the speed sensor. The speed sensor consists of a light beam, which the card on the top of the trolley cuts through. The speed sensor uses the time it takes for the card to pass through the light beam to calculate the speed of the trolley. Allow the trolley to run down the track, cut through the sensor, and record the speed. You can then calculate the acceleration.
To do this, we can use the equation A equals v squared minus u squared divided by 2s. V equals the final velocity, u equals the initial velocity, and s equals the distance travelled. In this case, u equals 0 because the vehicle started from rest, and s equals 1 metre. As u is 0, we can remove it from the formula. The equation consequently becomes acceleration equals final velocity squared divided by twice the distance, with the velocity being the speed as measured by the light sensor.
Let's look at an example. If the trolley was travelling at a speed of 3 meters per second when it passed the speed sensor, and it had travelled 1 meter by the time it had reached the sensor, its acceleration would be 3 squared divided by 2. This equals 9 divided by 2, which gives an acceleration of 4.5 meters per second squared.
Now you can carry out the experiment. Start with a 1 Newton weight, that's 100 grams, on the carrier. Increase it by 1 Newton each time whilst keeping the mass of the system constant. The way to do this is to make sure that there is always the same number of weights in use. Weights that are not on the weight carrier should be on the trolley. This is because these weights will not add to the accelerating force, but they will be part of the system.
Transfer the weights one by one from the vehicle to the carrier. Calculate the acceleration each time and enter the results in a table. You can then plot a graph with force on the x-axis and acceleration on the y-axis. The result should be a straight line with a positive correlation because the acceleration increases in proportion to the force applied. This proves that force equals mass multiplied by acceleration, or F equals ma. The vehicle has a constant mass, and the acceleration increased as the force increased.
For the next part of the investigation, you need to repeat the experiment as before, but this time you keep the force constant whilst placing the 100-gram masses on the trolley one at a time. You can keep the force constant by maintaining the same weight at the end of the cord. 100 grams equals 0.1 kilograms. The trolley and the rest of the equipment should be set up as shown.
In this experiment, the force will remain the same, but the mass will increase. We will be able to see how this affects the acceleration. Once again, you will need to calculate the acceleration of the trolley after each run. Plotting a graph of mass on the x-axis and acceleration on the y-axis should give a line with a negative gradient, as the acceleration decreases with increasing mass.
We can rearrange the equation F equals ma to give acceleration equals force divided by mass, or A equals F divided by m. Your results should show that if the force is constant, the acceleration decreases as the mass increases.